Okay, so Mr. Burke teaches a math class with 15 students. In the class, there are 6 female students and 9 male students. Each day, Mr. Burke randomly chooses one student to answer a homework question. And if they get it wrong, they are beaten. Seems reasonable. A. Find the probability that on any one given day, Mr. Burke chooses a female student to answer the question. So we need the probability that a student chosen at random is female. How many female students do we have? How many students do we have in total? Can we simplify that? Okay. In the first month, Mr. Burke will teach 20 classes. What type of probability is this? This is a binomial distribution. How do we recognize it's a binomial distribution? We have a set number of trials and a set probability of success. So let's put up our discrete random variable. X is the number of female students chosen. What's the smallest value that X can have? 0. What's the largest value it can have?
2.
20. X has 21 possible values it can be. It can be 0, 1, 2, 3, up to 20. We need to find the probability that X is equal to 8. We need to find the probability that X is equal to 8. X can have any number. X is the number of female students chosen over the 20 days. You could choose none. It could be a boy every time. You could choose only female students, and it could be 20. And it's going to be some number in between. So X is binomially distributed with a set number of trials of 20 and a probability of success of 2 over 5. So we need the probability that X is equal to 8. Can X be equal to 8.5? No, this is a discrete probability distribution. You can't have values in between. So we do this one on the calculator. We want menu, probability distributions, and then we've got, let's see if I can just get it to scroll there. We've got 2 distributions here. We are going to either use A, normal PDF, or we're going to use B, normal CDF. Normal PDF is to find a particular value when your probability has an equal sign in it. So when you say the probability is equal to something. CDF is we're going to find a collection of values, cumulative value. This is when your probability has an inequality in it, when it's less than or equal to or greater than. So we, for this question, are going to need a PDF, set number of trials, 20, probability of success, 2 over 5, and the X value we want is 8. We get 0.180. C. Find the probability that he will choose a male student at most 9 times. So on this one, we want to calculate. It's definitely a CDF question at most 9 times. Can you choose 1 male student? Can you choose 2, 3, 4, all the way up to 8, 9? Yes. So in this case, I'm asking this question because we're having to sort of think through, do we want 0 to 9? Or do we want to use a complementary probability of looking what happens together with the girls and things? And it's not that complicated, this question. So I think the best way forward is to set up a new discrete random variable where y is the number of male students chosen. So y is binomially distributed with 20 trials and a probability of success of 3/5. So we want the probability that y is less than or equal to 9. Take care with also deciding whether the final value is included. Is 9 included? If it's not, and we have a probability is less than 9, then you would have to find the probability. With a binomial distribution, you have to switch over to the probability that is less than or equal to 8. You always have to have it less than or equal to. So now we can just switch to the calculator. Menu 5B. Set number of trials is 20. Probability of success is 3/5. Lower bound is 0. Upper bound is 9. And we get 0.128.